Hello, welcome back to my YouTube channel. Again, this is Santos Capellan Jr. wishing you a very nice day. Okay, now today what I'm going to do is to give you an introduction to motor control. Okay, now because in my next videos, I will be starting the offline configuration of a BMS project. So meaning we will start our engineering works for a BMS project. So what I will do, I will select one BMS project. I will show you the BMS schematic diagram. Then based on that schematic diagram, we will try to configure our project. But this time it's only offline. When you say offline, we are not directly communicating to our controllers in the field. Okay, so we will just do the engineering works for a BMS project offline. Now, before I will do that, I will want to give you an introduction to motor control because as part of the scope of work of a BMS engineer is to understand or to have an idea how a motor control is being designed or fabricated. Okay, so because let's say you are going to control a specific equipment, let's say twin exhaust fan, the first thing you need to do is to finalize the BMS points for that equipment. Then make sure that the points for automatic operation of that equipment is provided in the motor control of that equipment. So someone, okay, so if you are the BMS engineer of a solution provider, someone will fabricate the control panel for the twin exhaust fan. Okay, so we are talking of twin exhaust fan or twin extract fan. So you will be having one control panel for that equipment. So the fabricator need to provide all the BMS points for that equipment. Okay, so they will provide the enclosure or the control panel, then provide some indication lamp, selector switch on the front cover of the motor control panel, then some protection devices and some electrical equipment inside the control panel such as magnetic contactor, overload protection, miniature relays, terminal blocks, control transformer, etc. Okay, so this video will give you an idea how to uh, do or how to design a motor control. Okay, but as a BMS engineer, that is not, it will be part of your scope, but it is not your responsibility to fabricate the control panel. So as a BMS engineer, you should have a clear understanding of how a motor control is working because sometimes you will do some checking. Let's say the control is not working, you have to check the control wiring diagram so that you will be able to fix whatever is the problem in the control panel. Okay, so without further ado, let me start this tutorial by showing you a I've already done some video in the motor control in my demo board. Okay, I'm using a demo board. I think if you are following this tutorial, BMS tutorial, you will be able to see this demo board. It is one of my video tutorial. Okay, now what I have here in my screen is the BMS showing a building management system that controls different system in a building like pumps, air handling unit, chilled water pumps, circulating pump, fire pumps, generators, heaters, exhaust fan, chillers. Okay, so this is the typical system that is being controlled and monitored from a building management system. So as a BMS engineer, you will be dealing with all of this electrical and mechanical and plumbing system. Okay, so let me show you let me start the introduction to motor control by showing you this pre-recorded video. Okay, so let me start this video. Minute, I have to share that video. Okay, let me share it first. Okay,
YouTube channel. Again, this is Mr. Santos Capellan Jr. wishing you a good day. Now today, what I'm going to do is I will give you an idea of how are you going to prepare your motor control for a certain equipment. Now, what I have here is my motor control, okay? As you can see here, I have several pilot lamps.
Okay, so I'm pointing the pilot lamps. Okay, so pilot lamps will give the indication of what is happening in the equipment. Now, this control panel is for, let's say, twin exhaust fan that will be controlled through this motor control. Okay, so what I'm using here is two small fans. Okay, these two small fans are 220 volts AC. Okay, so these fans are direct online. Okay, because it is too small, so you don't need to do some soft starting. So the power diagram here is done through direct online connections. Okay, so I'm using two contactors, one contactor for duty exhaust fan and another contactor for standby exhaust fan. Okay, so as I said, that we are going to do the introduction of this motor control for a twin exhaust fan. Okay, so let me continue that video.
Okay, these are the pilot lamps.
Okay, the green and red one are not pilot lamps. Those are push button switches. Okay, so I have there start and stop push button switches. This is start and this is stop push button. Likewise, I have also here one start and stop push button. Now this start and stop for duty, then this one for standby. Okay, so let me continue the video.
These are the pilot lamps. Then I have here start and stop push button. Now I have here a pilot lamp for power indication, meaning.
Now this one is important so that you will be able to know this power indication. You will be able to know if the motor control panel is already energized. As you can see here, the pilot lamp for power on is already lit. So meaning there is already power in the control panel. Okay, so you should be very careful in working on the motor control. Okay, anyway, my motor control here, my control voltage is only 24 volts. Okay, but even though it is 24 volts, you should be always careful in checking or doing some work in your existing motor control. Okay, so let me continue.
That the control panel is already powered up. Then I have here my fan 1 run status. Then this one is for the fan 1 trip status, fan 2 run status, and fan 2 trip status. Okay. Now, if you are designing your control panel, you have to know what are the information that you need to convey to the user or the one who is going to maintain your control panel. Okay. So here, I have here two selector switch. Okay. Now, what are the purpose of the selector switch? As you can see here, this is hand, off, auto. Okay, so off, hand, auto. Okay.
Okay, guys, the selector switch, as I said there in the video, the purpose of this is to run the equipment in manual mode. Okay, because let's say you have a problem with your DDC controller that controls this equipment. So if that twin exhaust fan is very important, you can run it manually. Okay, by putting the selector switch in manual mode. Okay, now. So when you put, let's say you put it in manual, then you can push the start button. Okay, so it will run manually. Okay, now BMS will only take the control if the selector switch is in automatic operation. So let me continue the video.
Now selector switch, we are using selector switch so that we can run the equipment in manual operation and automatic operation. Now, if it is in automatic operation, building management system will be the one to control the equipment. As you can see here, when I put it in automatic, you have seen that the pilot lamp indicates that the fans are running. As you can see.
Okay, now when I put it in automatic, the fans already run. Okay, so meaning it is already programmed in one of my controller, the operation of this twin exhaust fan, because when I put it in automatic, then immediately one of the fans it runs. Okay, so meaning the program downloaded or uploaded to the DDC controller is already working. So meaning my program, my control logic program does not detect any trip condition or any other condition that is included in my control program. So basically, my control program here is very easy. So before I will start the fan, I will make sure there is no trip condition or fault condition in my equipment. Okay, then if it is if it will stop during fire scenario, then I have to consider it that there is fire. When there is no fire scenario, then this fan will also work. So those are the sequence of operation, basic sequence of operation for a simple twin exhaust fan. Later on, I will be doing the control programming for this equipment. Okay, so I'm just giving you an introduction to motor control. So let me continue the video.
Above, I have two small fans, okay? So when I put it in off position, okay, as you can see here, these fans will stop, okay? Now, today, what I'm going to discuss is how are you going to prepare your motor control panel, okay? Now, as you can see here, this is a small motor control. This is my enclosure, okay? So,
okay, guys, as you can see, inside the enclosure, you did not find the contactors or the control transformer because if it is a small enclosure, I decided not to put the contactors and the overload protection inside the enclosure for ease of wiring, because later on I will be showing you the how you are going to wire the power diagram and the control wiring in manual and automatic operation of this control panel. Okay, so that's why I did not put it inside for better viewing when I will do the power diagram and control diagram. Okay, so let me continue.
So these are the connection at the back. Later, I will be showing you how to do the connections. Okay. Now, for the enclosure, you need to see to it that that this panel will be installed inside a room or outside the room. When you are going to install this outside, now you have to check the IP.
Okay, guys, now I'm discussing here the installation of a control panel, because the control panel, you can install it inside the building, okay? Then you can also install it outside of the building, let's say rooftop, okay? Now, if your control panel will be installed outside of the building, let's say in the rooftop, now make sure that your control panel is IP67, meaning it can withstand moisture, rain, okay? So it will not damage whatever device you have inside your control panel, okay? Now, if it will be installed outside, all the cable entry should be from the bottom of the control panel. And all this indication lamp, selector switch, then push button, it should be installed that it will withstand moisture or rain. So it should be IP67. So once the panel will be installed outside, you have to specify to the panel fabricator that this panel will be installed outside of the building. So you have to provide IP67 protection and make sure that this indication lamp are waterproof. Okay, so water or moisture will not enter in this indication lamp and this selector switch and push button switches. Okay, so when it is will be installed inside the building, then you can have this IP rating, let's say IP 50, It should not be waterproof, okay, if it is inside the building. Okay, so let me continue the video.
The rating of the panel, because if it is, it will be installed outside, the IP rating should be IP65 or IP67, okay? So it will not be damaged by moisture or rain if you are going to install it outside area, okay? So those are the information that you need to check where this panel will be installed, okay? Now, so this is the front face of the motor control. Make sure you will provide some pilot lamp to give some indication if it is running or there is fault. So make sure also that you will select the correct color coding. Basically,
okay guys, actually, when I say you have to select or do color coding, as you can see here, I have green. Basically, you will use green for run status, then red for fault or trip status. Then you can use blue for power indication. Now, guys, for this one, the fabricator or the panel motor control fabricator will be the one to decide with the color coding, okay? Because the electrical engineer, the one that will order the motor control for this twin exhaust fan, he will be the one to specify the details of this pilot lamps, okay? So I'm just giving you an idea if you will be the one, okay, let's say you are the one to fabricate the panel, so I'm just giving you an idea, okay? So let's continue.
we are using green for run and red for fault or trip, okay? Then you can provide power on indication. Then you need to provide also push button switches. I have here 2 push button switches. These 2 start and stop for one of the fans. Then these 2 push button for the other fans. Okay. So basically, this is the basic configuration of a small control panel. Now, what are the devices inside? As you can see here, I don't have any. I don't have here my contactor. What I have here is the fuse holder for the protection of the pilot lamps. Okay. Now, for the selection of pilot lamps, you have to select properly. For a motor control, for the control voltage, basically it will be 24 volts. So all you need to do is select this pilot lamp, the correct voltage for this. So as you can see here, these are all 24 volts pilot lamp. Okay. Now, for the contactor, magnetic contactor, I did not put it inside the control panel for some reason, because this is only a small panel. It will not fit this magnetic contactors. I have here 3 magnetic contactor, as you can see here. Now, since I will be using a small motor like this, small fans, okay. Now, I will be connecting it or connecting this motor direct online, because these 3 contactors, you can use this for Y delta starting. Now, since this is only a small fans, so I will be using direct online. Okay. Now, later in my upcoming videos, I will show you how you are going to do the power connection or the power diagram and the control diagram and control wiring connection. Okay. Now, for the time being, I'm just showing you the magnetic contactor and the overload protection. Okay. Now, basically, you need to provide some protection for your motor. Okay. So, to provide protection, we are using overload protection. So, I have here an overload protection. So, what are the details here? As you can see here, you can do the test. You can test it. Okay, then if it trips, you can also reset. Okay, then you can set the correct setting for the amperes. Okay, now how are you going to set the amperes? Now, first you have to check the motor nameplate. You have to check what is the full load current of the motor. Then based on that information, you will select the, you will set this overload protection. Let's say your motor full load current is 7 amperes, then you have to at least set this to maybe 7.1 or 7.2 amperes. So when the current zone reaches 7.2, then this overload protection will be activated, then it will cut the power supply to your motor.
Okay, guys. Now, actually, I'm showing here an overload protection. Now, the maximum current is 8 amperes. So when I say if the full load current of your motor is 7 amperes, you can select, you can set this overload protection in the middle of maybe 7.2, 7.3, or 7.5. Okay. Now it depends. It depends on you if you want to put it in 7.4 or 7.5. Okay, so maybe if you are not an electrical engineer, you can ask the electrical engineer of your project for if he can help you to properly set the correct setting here. But for me, I can set it to 7. If my full load current is 7 amperes, I will set it to 7.2 to make sure that when it go above 7.2, then my overload protection will work. Okay, so let me continue.
Okay, so I have also here some small relays, okay, miniature relay.
No, actually, these relays, I'm using this for automatic operation or automatic control wiring diagram for this twin exhaust fan. Okay, because as you know, when you are doing the BMS, the different BMS points for this twin exhaust fan should be provided from motor control to your DDC IO module. So you need a bolt-free contact coming from the motor control. So I'm using this miniature relay to provide to me or give to the DDC the bolt-free contact like run status, the run status from NCC, then the trip status, the handoff auto status to the DDC, from MCC to DDC. Okay, so this is the use of this miniature relay
that I'm using for my automatic operation. Okay. Now, in my next video, I will be showing you how we wired this control panel. So this is just an introduction to motor control panel. Okay, so as you can see here, I have also some protection devices here like these circuit breakers. Okay, to provide protection also, I installed some MCB. Okay, so this is how you are going to design a motor control for a specific equipment. In this case, this is only 2 small fans. Just to simulate the operation of an equipment, we are using 2 small fans. Okay, so I think this is enough for today. Thank you very much for watching this short video clip. And again, this is Santos.
Okay, guys, so I do hope I have given you some idea how you are going to fabricate or design your own control panel. Now, actually, as a BMS engineer, this is not your scope to do all this work, let's say this fabrication and all this wiring, power diagram and control wiring diagram in manual and automatic operation. Now, I'm just giving you an idea. As a BMS engineer, you should be capable of troubleshooting the control panel. Now, in my next video tutorials, I will be doing the power diagram first of this control panel. Then after power diagram, then there will be the manual control diagram for manual operation. Then after manual operation, the automatic operation. And I will show you how are you going to provide the BMS points from this motor control to the DDC, okay, for control logic programming. So again, guys, I think I have given you an idea as a BMS engineer, how are you going to design or fabricate a control panel. Okay, so once again, thank you very much for watching this video tutorial, and I do hope it will be able to help you. If you are a new graduate of engineering course, you are planning to join MEP company, or you want to be a BMS engineer, I hope I can produce BMS engineer from my tutorials. Again, thank you very much. And Santos Capellan Jr. saying God bless us all and bye for now.